Balance the following equation in acidic solution using the lowest possible integers and give the coefficient of water. The equation involves I2 solid plus S2O3 2 minus aqueous, producing S4O6 2 minus aqueous and I minus aqueous. So first, to solve this problem, we need to balance this redox reaction in acidic solution. The steps to do that is as following. Step 1 is to assign oxidation number to each element in the equation. So first, I'm just going to rewrite the equation. Next, let's talk about I2. So it's a free element, and free elements will have the oxidation number of 0. So oxidation number of iodine here is 0. Next, looking at S2O3 2 minus, this is an ion. So for ion, all oxidation number must add up to the charge of the ion. So if we have the oxidation number of sulfur is X and oxidation number of oxygen is -2, we'll have an equation of 2X plus 3 times -2 equals to the charge of the ion, which is -2. And if we solve this equation, we'll have X equals +2. And so the oxidation number of sulfur in this compound is +2. Moving on to S4O6 2 minus. Again, this is also an ion, so all oxidation number must add up to the charge of the ion. If we have X as the oxidation number of sulfur and -2 is the oxidation number of oxygen in this compound, then we'll have an equation of 4X plus 6 times -2 equals the charge of the ion, which is -2. And if we solve this equation, we'll have X equals +2.5. So +2.5 is going to be the oxidation number of sulfur in this compound. Next, for I minus, this is an ion, so the oxidation number of an ion is the same as its charge. So if it's I minus, then the oxidation number for I minus is going to be -1, the same as its -1 charge. Moving on to the next step, that will be to identify the oxidation and reduction half reactions of this redox reaction. So we see how iodine going from 0 to -1 oxidation state. So that's going to be a reduced in oxidation number. So we can identify that that's the reduction half of the equation. And then for sulfur, we see it goes from +2 to +2.5. So that's an increase in oxidation number. So that's going to be the oxidation half reaction. So once we identify the two half reaction, let's write them down. The oxidation half is going to be S2O3 2 minus becoming S4O6 2 minus. And for the reduction half reaction, that's I2 becoming I minus. Moving on to the next step, we'll balance out elements that is not oxygen or hydrogen. So let's look at the oxidation half. We have 2 sulfur atoms on the left and 4 sulfur atoms on the right. So to balance it out, we'll need 2 S2O3. So that's going to make a total of 4 sulfur atoms on the left, and that's going to balance out with the 4 sulfur atoms on the right. Now let's look at the reduction half reaction. We have 2 iodine on the left and 1 iodine atoms on the right. So to balance it out, we'll need 2 I minus on the right, so that both sides have 2 iodine atoms. Moving on to the next steps, that will be to balance out oxygen by adding H2O. So let's check out the oxidation half. For the oxidation half, because we have 2 S2O3, so that's going to be a total of 6 oxygen. And then on the right, we have S4O6, so that's going to be 6 oxygen. So now it's already balanced. Both sides have 6 oxygen, so we don't have to add H2O to either side. Next, let's look at the reduction half reaction. On the left, there's 0 oxygen, And same thing on the right, there's also 0 oxidation, so it's already balanced out, so we don't have to add H2O to either side. Moving on to the next step, step 5 is about balancing hydrogen by adding H plus to either side. So, looking at the oxidation half, we have 0 hydrogen on the left side and 0 hydrogen on the right side as well. So the number of hydrogen on both sides is already balanced. They're both 0, so we don't have to add H plus to either side. Now let's look at the reduction half. Also 0 hydrogen on the left and 0 hydrogen on the right. So the number of hydrogen on both sides is already balanced, so we don't have to add H plus to either side. So moving right on to the next step, we need to balance out the charge by adding electrons. So let's looking at the oxidation half. We have 2 S2O3 2 minus. So that's going to be 2 times -2 to give a total of -4 charge on the left. And on the right, we just have 1 S4O6 2 minus. So that's going to be a -2 charge on the right. So to balance it out, we need to add 2 electrons to the right. So the 2 electrons provide an additional -2 charge to add on to the -2 to give a total of -4 charge on the right. So now both sides have -4 charge and is balanced. Now let's do the same thing for the reduction half. For I2, it's a neutral compound, so it has 0 charge. And then on the right, we have 2I minus, so that's going to be a total of -2 charge. So in order to balance it out, we need to add 2 electrons to the left so that it provides a -2 charge to the original 0 charge, and now both sides have -2 charge. And that's it for step 6. Moving on to step 7, we need to multiply each half reactions to have the same number of electrons involved. So checking on the oxidation half, there are 2 electrons involved in the oxidation half, and in the reduction half reaction, there's 2 electrons involved as well. So we see that both half reactions already have the same number of electrons, which is 2, so we don't have to multiply any of them by any number. So now we come to the last step, which is to add the 2 reactions together and cancel out the electrons as well as any other common terms. So now we just need to add the oxidation half with the reduction half reactants together and products together. And that's going to be 2 S2O3 2 minus plus I2 plus 2 electrons producing S4O6 2 minus plus 2 electrons plus 2I minus. So, like they said, we can cancel out the electrons. But other than that, there's no other common terms on both sides. So that will be it for us. And we can rewrite to have the final balanced equation involve 2 S2O3 2 minus plus I2 producing S4O6 2 minus plus 2I minus. So now that we got the final balanced equation, we can go back and answer the question, which is what is the coefficient of water in this reaction? And the answer is going to be 0 because H2O does not appear in the final balanced equation. And that's the answer to this problem.